Introducing Atom's MaxFlex, full nonlinearity in multi-body dynamics. Greater emphasis has been placed in recent years on high-speed, lightweight, precise mechanical systems. Often, these systems will contain one or more structural components for which deformation effects are paramount for design analysis. In those cases, including the flexibility for those key components results in a more precise loading prediction and improved system performance prediction. Atom's Flex has been used by Atom's users for many years to include linear flexibility into multi-body dynamic systems, and allows one to capture relatively small deformations of flexible components, up to roughly 10% of the characteristic length, during a simulation. However, when it comes to components with geometric or material nonlinearity, like the twist beam in a suspension system or engine mounts, the traditional flexible bodies do not provide the capability to cope with nonlinearity in the simulation. Hence, to incorporate the nonlinear flexibility into multi-body dynamic systems, we are introducing Atom's MaxFlex to the industry. Based on the implicit nonlinear finite element analysis, Atom's MaxFlex allows for the representation of geometric nonlinearity, material nonlinearity, and boundary condition nonlinearity in Atom's models. While FEA technology is used to represent and solve the nonlinear flexible body, it is embedded wholly within Atoms so that no additional FEA software is required to solve the model. MaxFlex can be used in any scenario where the engineer wants to capture nonlinearity in their multi-body dynamics models. For example, in the automotive industry, it can be used to simulate the twist beam suspension, stabilizer bars, coil springs, suspension bushings, rubber mounts, lower control arm buckling, and so on. In the aerospace industry, one can apply MaxFlex in control surface deployment, wing bending for UAV or airplanes, helicopter blades, and etc. Other use cases include wind turbine blades, high-fidelity spring models, and many more. Here are some reasons to use MaxFlex. Using Atom's MaxFlex, an MBD analyst can increase model accuracy by including nonlinear structural behavior. Simulation is conducted entirely in Atoms. It's easy to set up models and run simulations with similar workflow as Atom's Flex. There is a shared memory parallel support to increase simulation efficiency. No third-party tool is needed to generate animations with both rigid and nonlinear flexible parts, since it can be done entirely in Atom's post-processor.